All right, today we're going to talk about something you use every single day, probably without even thinking about it. It's this powerful piece of tech that seems to know what you want before you do. We're talking about recommendation engines. So let's pull back the curtain and see what's really going on inside. I mean, have you ever wondered how that happens? You finish a movie on Netflix, and boom, the perfect next one is right there. Or you're on Spotify, you hear a song and it lines up this amazing track from a band you've never even heard of, but you instantly love. How does it do that? Is it like reading your mind? Well, no, it's not actually magic, but it's pretty darn close. This is one of the coolest, most powerful uses of data science out there. It's a whole system designed to figure out your tastes and just serve you the perfect thing. And today, we're going to break down exactly how it pulls that off. And you gotta understand, this isn't some obscure niche tech. This is the absolute backbone of the biggest platforms on the planet. We're talking about the movies Netflix suggests, the stuff Amazon puts in front of you, even the way Google predicts what you're searching for before you even finish typing. They all use these engines to build an experience that's just for you. Okay, so how do these things actually, think? It turns out they pretty much follow one of two main strategies to make their predictions. And if you can get your head around these two paths, you've basically unlocked the whole concept. Okay, on one side, you've got what's called content-based filtering. This one's all about the item's DNA, its features. It looks at a movie you liked and says, okay, you liked Inception. That's a mind-bending sci-fi thriller. You'll probably dig Interstellar. Simple enough. But then on the other side, you have collaborative filtering. This one doesn't really care about the movie's genre. It cares about people. It finds other users who have tastes just like you and says, hey, lots of other folks who loved Inception also went nuts for The Matrix. You should probably check that one. And this analogy just makes it so clear. A content-based system is like that awesome shopkeeper who remembers everything you've ever bought. But a collaborative system, that's the shopkeeper who knows what other customers with your exact same taste have been enjoying. Now here's the real secret sauce. The big players, Netflix, Amazon, they actually use a hybrid of both. They mix and match, combining the strengths of each. So you get recommendations that aren't just based on your personal history, but they're also supercharged by the wisdom of millions of other users. It's really the best of both worlds. Okay, theory's great and all, but let's get our hands dirty, right? How would we actually build a simple recommendation engine from the ground up? Let's just walk through it, step by logical step. First things first, you need data. And I mean a lot of it. For an example like this, you'd be working with something like the famous Movie Lens dataset. Get this, it has 26 million ratings for over 45,000 movies. That's the fuel for our engine. Now we can pretty much boil the whole process down to 3 key steps. First, and this is the really clever bit, we have to translate all those words, plot summaries and genres, into a language the computer can actually understand, numbers. Once we've done that, step 2 is to use some pretty slick math to figure out the closeness between any two movies. And then, finally, the easy part, we just rank all the movies by that similarity score and recommend the ones at the top of the list. So for step 1, turning words into numbers, we use this tool called a TF-IDF vectorizer. Just think of it like a translator. It reads through a movie's description and turns all that text into a unique numerical signature. Data scientists call this a vector, which is really just a fancy way of saying a long list of numbers that represents the movie's key features. Isn't that cool? It's like we're creating a mathematical DNA sequence for every single movie in our library. Okay, now here's where the real magic happens. Since every movie is now a point in this massive multidimensional space, we can measure how similar they are by literally calculating the angle between their vectors. This is called cosine similarity. Think about it. If two movies are about the same kind of stuff, their numerical DNA will point in a very similar direction, right? So the angle between them is going to be tiny. And that tiny angle, that's exactly what we're looking for. And what you get is a really simple score. A score of 1 means the movies are a perfect match, content-wise. A score of 0 means they have absolutely nothing in common. So when you ask for a recommendation, the engine just calculates this score between your favorite movie and every other one in the database, and then it shows you the ones with the highest scores. Simple, right? Well, mostly. Because see, there's a huge flaw in these simple systems. It's a real-world problem that developers absolutely have to solve to make the recommendations feel fair and accurate. And it's called the popularity problem. So let me ask you a question. Just looking at the ratings, which of these two movies is really the better one? A simple system would just look at movie A, see that 9.0 rating, and go, yep, that's the winner. But wait a minute, that 9.0 was only based on 25 votes.
Movie B, on the other hand, has an 8.5, but that's backed by a whopping 25,000 votes. Our gut tells us Movie B is the more reliably great film, right? So we need a system that doesn't just blindly favor movies with a few super high ratings.
This analogy just hits the nail on the head. The system needs to be like a smart judge who knows that getting a 9 out of 10 from a stadium full of people is way more impressive than a perfect 10 from 2 parents in the front row. It has to account for both the score and the weight of the audience behind it. And the solution is a smarter formula, something called a weighted average. It creates a much more balanced score because it factors in not just the average rating, but also the number of votes it has, usually compared to some minimum threshold. This makes sure that the popular, proven hits get the credit they deserve and don't get drowned out by some lucky niche films.
Okay, so we've looked at the main strategies, the step-by-step logic, and a major problem that needed a clever solution. Let's bring it all together now and connect these building blocks back to the apps you're using on your couch every single day. Because really, that's the big takeaway here. Those incredibly sophisticated, complex systems at Netflix, Spotify, and Amazon, at their heart, they're built on these very same principles. Sure, they use way more advanced models, but the basic logic, turning content into numbers, measuring similarity, and ranking things fairly, that remains the absolute core of what they do. So the next time your favorite app serves up a recommendation that just feels impossibly perfect, you'll know the secret. You'll know it's not some kind of magic. It's this beautiful piece of data science, a conversation happening between your personal tastes and the patterns of millions of other people. You know the recipe now. So my question for you is, what are you going to notice differently?